Let's look at worked example 4.12 from the textbook. Predict whether each of the bonds between the following atoms would be ionic, polar covalent, or nonpolar covalent. If polar covalent, which atom would carry the partial positive and negative charges? Example A is capital C or carbon and capital B lowercase r or bromine. Example B is capital L lowercase I or lithium and capital C lowercase l or chlorine. Example C is capital N or nitrogen and capital H or hydrogen. Example D is capital S lowercase I or silicon and capital I or iodine. Pause the video and determine the answers to these four examples. To determine the polarity of each bond, we need to find the difference of their respective electronegativity values. Looking at our first example of carbon and bromine, we see from figure 4.6 that carbon has an electronegativity value of 2.5, while bromine has an electronegativity value of 2.8. When we subtract the smaller value 2.5 from the larger value 2.8, we get an answer of 0.3. Since any electronegativity difference between 0 and 0.4 is considered to be nonpolar covalent, this is a nonpolar covalent bond. The electrons in the bond between carbon and bromine can be considered to be shared equally. In part B, we have lithium and chlorine. According to figure 4.6, lithium has an electronegativity value of 1.0, while chlorine has an electronegativity value of 3.0. The difference between 1 and 3 is 2. Since atoms that have a difference in electronegativity that is 2 or greater are considered to be ionic, this is an ionic bond. There are no partial charges here. Lithium has a full positive 1 charge and chlorine has a full negative 1 charge. Each ion has an unequal number of protons and electrons, and they are not sharing electrons. Example C is nitrogen and hydrogen. Figure 4.6 from the text states that the electronegativity value of nitrogen is 3.0, while hydrogen has an electronegativity value of 2.1. When I subtract the smaller value of 2.1 from the larger value of 3.0, the result is 0.9. Differences in electronegativity values between 0.5 and 1.9 are considered to be polar covalent. Since nitrogen has the higher electronegativity value of 3.0, it is assigned the partial negative charge, and hydrogen has the partial positive charge. Nitrogen and hydrogen form a polar covalent bond with unequal sharing of electrons. Nitrogen exerts a greater attractive force on the bonding electrons than hydrogen does. Our last example is between silicon and iodine. According to figure 4.6, silicon has an electronegativity value of 1.8, while iodine has an electronegativity value of 2.5. The difference between those values is 0.7. Since this value is between 0.5 and 1.9, this is a polar covalent bond. Since iodine has the larger electronegativity value, it is assigned the partial negative charge, while silicon has the partial positive charge. There is an unequal sharing of electrons in the covalent bond between iodine and silicon, as iodine is able to exert a greater attractive force over the bonding electrons.